uh, Radovan Kopecek, who is the Managing Director of Advanced Cell Concepts at ISC Konstanz. He's also executive committee member. He's going to talk about the future of copper screen printed bifacial XBC for utility scale. Radovan, floor is yours.
Yes, thank you, Shravan, for the introduction, and of course also for the invitation for this workshop. It's really amazing. So congratulations! What kind of program you designed? What a crazy year! This was really a very turbulent year. The prices are going down, much too down, I would say. And the technology is changing very fast, also quite fast. We also have to take care that there will be not so much degradation out there in the NPV era. But I hope that all the manufacturers know about this new technology. And so thank you also for our Chinese friends for climbing all the mountains in Himalaya. Fortunately, in Europe, we have smaller mountains, so hopefully we will also succeed in future to bring PV back, production back. So I'm these days extremely excited, not only because now we are entering the NPV era, but because it's also the last talk of the year, and ISC Konstanz is now 18 years old. So we are getting in age, and we can do many things now. So first of all, I will show you some slides about ISC Konstanz, then about XBC solar cell technology in general, because there are so many back contact technologies out there. I just want to sort it out, that you know what people are talking about. Then this year in November we had the back contact workshop, so I would like to show you the outcome, and then I will disclose what we are doing in the large European project going copper screen printed bifacial technology. And the goal is actually to bring bifacial IBC to the utility scale, which to my opinion will go quite fast. So ISC Konstanz, we are now growing, 65 people exclusively working on crystalline silicon photovoltaics. The achieved solar cell efficiency in production 24.6. I mean, this is not a very impressive number if you compare to all the 25, 26%, but it's the highest efficiency for a solar cell without any passivating contacts, which is our Zebra technology. And at the moment, we are working for upgrades. So we are working on Zebra 2.0 and 2.5. I will explain you later what that means. So we are founded in 2005, as I told you, and we are transferring technologies out there, so not only in China but also in India. So we have 8 transfers from 2015, where we started in Italy, and then we have 10 transfer plans in the next years, Asia, Africa, US, but also, let's say, the final goal is to have also cell production in Europe. So my last slide about ISC Konstanz, I'm very happy. We are now 18 years. So this is the pictures from 18 years ago, and this is me. I changed a little bit from them. And but what I want to show you is actually from the beginning on ISC Konstanz, we have been working on N-type technologies, and this was our major focus, bifacial N-type. So this is a slide from December 2006, which we showed to our advisory board. At that time, it was Bosch and others, that we have to move to N-type, because for terrestrial application, N-type is much more interesting, and this is what is happening at the moment. So that's why I'm extremely excited to work on N-type technologies. So why back contact will win? Also because Martin Green is now also announcing that he believes that back contact technology might be the, let's say, the final solution, the final high efficiency of crystalline silicon technologies. There was this plenary in Asian PV conference in November showing our graphs. So actually to show you what is out there and to explain you all the back contact technologies, I am leaving out heterojunction because heterojunction will be then also similar to what is happening with the TOPCon back contact. So in general, we can call it XBC, what people are doing now. So I already explained Zebra technology has no passivating contacts, and that was more or less an upgrade of our Bison endpoint technology. This is still in production, but not strong enough because now we have to be compared to TOPCon. And what other companies are developing, you just heard the talk from Longi and also Tongwei are working on this technology is P-type. But let's say the final goal, I call it always the holy grail, is what ICO has shown now, and Maxeon is already producing it for a long time. At the moment, all these technologies are copper plated, and our idea is actually also to go towards screen printing with the Copprint. And I think you will hear a more detailed presentation about that later on from Offer. So these are all the technologies out there. And I think this is also quite confusing because if people are talking about XBC, they mean many options out there. So when we come to a standard similar to TOPCon is now more or less standardized, then XBC will enter the next level. At the moment, how the spread of N-type technologies out there is looking like, of course, there are TOPCon and heterojunction believers. Mostly, there are 80%, I would say, of the industry still believes that TOPCon and heterojunction will remain for a long time, and then maybe tandem technologies will follow. However, in order to really have this upgrade of crystalline silicon technology, you somehow have to go a step further. And to my understanding, XBC is the best solution. So for example, Q-Cells and Trina, I mean, they have a history in development of back contact technologies, and they have realized in the past that this is a quite expensive technology. However, at that time, the polysilicon depositions were not developed yet. So now we have quite easy, you have heard about it, LPCVD, but we prefer PCVD, polysilicon deposition, and it's quite easy to do it with boron, with phosphorus doping. What is not so easy at the moment is still the boron doping, but there are workarounds. So you can also do boron diffusion still. And this is what we are doing, and I will show you later on. But to explain you here, we have already Longi, ICO, and many others. Also, we are working with FuturaSun, have realized that in order to be to have, let's say, a better product than the mainstream, they have already to go to so-called XBC. And there are also possibilities to go to tandem. Of course, 4-terminal tandem or 3-terminal tandem is possible at that way. So I think you know the famous graph of Finley, how NPV was entering the market, and now I somehow adapted it towards XBC, how the migration could work. So of course we had SunPower, Longi, SPIC, and ICO as innovators, then early adopters. But let's say the transition from one technology to the other starts when really the mainstream is picking on. So Longi also going now towards XBC, like with the TOPCon structure, so N-type. Then we can have also Jinko, JA Solar, and Tongwei maybe earlier because they are already working on it. So my forecast is that actually in 2030 or even slightly before, we will have larger mitigation, migration of back contact technologies. And that's why we also started with back contact workshops. And here are some pictures from the workshop. It was in November this year in Hameln. And so we had a very interesting discussion round. Also, Gianluca was on that. And then we had Tongwei, Maya Burger, Trina, and also Peter from RCT. And I was watching this discussion very carefully. And actually what comes out that at the moment, I think the most difficult thing for XBC is that we are not talking the same language, like building the Tower of Babel somehow. So that means that XBC community is getting bigger, similar to the old times, you know, when we were organizing bifacial workshops and PV. So it's getting bigger now, but there are too many concepts out there. So P-type, N-type, different passivation. So despite of this, XBC will come to a 2-digit gigawatt scale, as we already learned. So ICO is upgrading and Longi. Then let's say the first XBC is, of course, for rooftop market, and I call it XIPV. It's like building integrating photovoltaic. But I'm quite sure that actually very soon it will also come to utility scale market. And there has to be more or less 2 or 3 things to be considered. We have to go to copper metallization to make it lower cost, and also, let's say, to solve the polysilicon boron passivating contacts issue, that it goes also as easy as for TOPCon the phosphorus doping. But there are already cases, and we have listened to a final talk of a back contact workshop that already some installers and utility scale suppliers are actually already thinking about using XBC from ICO, so ABC, and if it will be bifacial, and I will show you some slides that actually now ICO is also going towards bifaciality. That will make it much more easier also to compete with TOPCon and heterojunction. So now about IBC4EU project, what is the goal there? So it's a big European project with a 17 million budget, and we have many partners. The most important one for this presentation is FuturaSun, because we are partnershiping with them to bring our Zebra 2.5 into production. Then Copprint, you will also hear some more presentation about the copper screen printing later on. And the goal is actually to bring bifacial XBC into utility scale. That means we have to make it the IBC concept more bifacial and low cost. And in the project, we are working on 2 different topics. So ISFH is working on the Polo IBC, so similar to the P-type technology you just saw from Longi. But let us focus now on the Poly Zebra, the Zebra 2.0 or 2.5. And there we have Copprint, ISC Konstanz, Valoe, and FuturaSun. So the goal is actually to reach efficiencies above 25%, going to 740 millivolts. And the innovation is actually that we will use PCVD-based polysilicon depositions for that. And there we have our partners, Centrotherm, but we are also working, and I think you will hear about that later on PVD depositions with von Ardenne, and further developing our back contact technology. So now, how to implement copper cost effectively into an IBC cell? Of course, plating works, but to my understanding, it's quite complex and complicated. So our idea to make it really cost effective go to copper screen printing. And for that, we are working with Copprint, and the paste is somehow magical paste because it's not oxidizing. So that's the know-how how Copprint can make a paste without using silver particles to cover the copper. They are using some different ingredients, and so it can be screen printing very well. Let's say not as shallow as it will be necessary for the front side, but still it can be for IBC concept. You can here see the picture that you can screen print it very well. And what we are using at ISC Konstanz is for the firing through, we still are using silver. But nevertheless, if you look at the ITR PV roadmap, we are already in the year of 2035 that we are only using 5 milligram per watt peak solar cell because of the silver used here, which is used for firing through, then making the contact, and also making the protection from the copper in diffusing into the substrate. And as I said, you will hear about that more from Offer. But let's say the next generation, as I told you, is not the Zebra, but it's the Poly Zebra, so Zebra 2.0 with passivating contacts. And lately in the project, we have reached now efficiencies at 24%. And for a laboratory process on large area, this is quite nice. But of course, the goal, which we will reach in the coming weeks and months, is going above 25%. If transferring this technology, we are even gaining efficiency because it's a lab process and we don't have, let's say, the purity as required in production. So here you can see the Zebra process, which is now used at SPIC and Valoe, and we are going now to the Poly Zebra. As I told you, let's say all the processes are standard, so very close to what you have for Zebra or TOPCon. The only challenge, and there are workarounds, is how to make a very good and homogeneous and stable boron diffused polysilicon. It is not as easy to do it in situ doped with PCVD, but we are using the boron diffusion and it's working very homogeneously. Let's say the next step would be also to implement into PCVD or PVD the boron diffusion in situ. And I have promised some bifacial pictures. So actually, I think you know that Zebra, and we have displayed it already many times, is bifacial. Now ICO is also going bifacial, and this is a picture from the show in Asia, in Shenzhen. And as we are speaking, ICO is now also having a ceremony in China and launching the bifacial ABC product. So the next step of XBC technologies is that they are now going bifacial. So what's the next step for ISC Konstanz is to further develop the Zebra and use it then in cooperation with FuturaSun and Copprint for industrialization, then support also other countries, Europe, EU, US, and India with the production of XBC bifacial and also further development of Zebra 3.0, as I told you, to make the polysilicon boron deposition simpler. So in summary, PV is entering the bifacial N-type era, and I'm extremely excited about that because I started with that already a couple of years ago. N-type book is now being copied. So we have written N-type book. This is the original. And actually I bought one from US and it came from India and it's being already copied. So it's a good sign. N-type is important. You can see it on this word, economics. It's instead of economics. So that's an Indian copy. TOPCon is the next mainstream. This is clear. Heterojunction XBC are meant for rooftop. And XBC will be the next mainstream. And I wish you a relaxing Christmas holidays. That's my last sentence of this year. Thank you.
Thanks a lot, Radovan. That was really very nice presentation. And sorry that your book got copied, but in a way, it's good that the knowledge spreads. You know, one question, you talked about the efficiency potential and how it goes. So can you say something on the cost level? So where are you with your Zebra previous one and Zebra Poly? If you introduce Poly into the Zebra equation, so how the costs are going to look like?
Yes, that's a very good question because ISC Konstanz is, let's say, one of the few companies, or let's say few institutes that are going the bottom up approach. Many are going the top bottom approach, and then of course the cell is costly. We are using the same equipment as for PERC or TOPCon, so it's very close to all these technologies. So at the moment, I think, let's say, if you compare cost per watt peak for our Zebra technology is same as TOPCon, but of course TOPCon these days has a higher voltage, so it doesn't make sense to compare it with Zebra. But for Poly Zebra, it's about 2 to 3 cents per watt peak more expensive at the moment. But of course, if let's say we standardize all the equipment like the boron, polysilicon and things like that, it can go at the same cost as TOPCon, I would say. You are muted, Shravan.
Yeah, sorry. Thanks a lot. And if there are any questions in the chat window, please try to answer while enjoy our conference.